Good morning everyone. Today we are going to start with a new chapter, Lesson 3, Atoms and Molecules. Right? Now you have studied about matter, that everything around us is made up of matter. So these Indian philosophers, they were just wondering, they were thinking how these matter is made up of, what this matter is made up of. You all know, this was known that matter is made up of very small particles. So one of the great Indian philosopher, Maharishi Kannad, he said, or he postulated, that if we go on dividing any matter into smaller particles, we reach a stage when it cannot be further divided. That particle cannot be further divided into any smaller particle. And this smallest particle, that he named as Parmanu. Right? Parmanu. If we just break it, this is a Hindi word, Parmanu. Right? And if we break this word, it becomes Param Anu. Anu in Hindi means kan, बहुत छोटे छोटे कण. परम मीन्स बहुत ज्यादा छोटे, मतलब एक्सट्रीम में. तो बहुत जो छोटे कण होंगे उनको नाम दिया गया परम अणु, परमाणु. Right? So he gave this word. Then further other philosophers also, they kept on working on this. Another philosopher, Katyayana, he said that these particles, they can, how can we form different forms of matter out of these particles? Right? How these can be formed? Then in the same era, there were some Greek philosophers also, like Democritus and Leucippus. They were also working on this. So this Democritus, he also said that matter cannot be further subdivided. Like these, the smallest particle, he named it as atom actually. He gave the word atom to the smallest indivisible particle. Atom actually means indivisible. So the Indian philosopher, he gave the name Paramanu, and this Greek philosopher Democritus, he gave the smallest particle which cannot be further divided the name atom. Then after that, when all this was known that this smallest particle or the atom cannot be further subdivided, then another scientist, they kept on working on it, and slowly they came to know about when this element were discovered, and they knew that when elements combine together, they form compounds. So they started working on this now, that how the elements can be combined together, or how this matter can be formed by combining the particles. This because Katyayana, he said that matter cannot exist, or these particles cannot exist alone. Right? They combine together. So now, how these can combine together? So, two scientists, Lavoisier and Proust, right? J.L. Proust. So they gave two laws of chemical combination to explain how they can be combined together. They gave two laws of chemical combination. The first law, that is law of conservation of mass as given by Lavoisier, it states that mass can neither be created nor destroyed in a chemical reaction. Now to prove this, we'll see this experiment also. how to prove that mass whenever a reaction takes place. That means some things are combining together. So he said, according to him, whenever any reaction takes place, the mass remains the same. Whatever is the mass of the reactant will be the mass of the product which will be formed after the reaction. So we just prove this law by the help of an experiment. We take a conical flask. This is known as a conical flask. And in this conical flask, we can take any compound, any material for like two substances which can react. So in this we take sodium carbonate, right, in the conical flask, and then we hang with the help of a thread. We hang a test tube in this, and in this test tube there is a solution of copper sulfate, right? We put a rubber cork on this so that it is airtight now, and we weigh this flask, right, along with sodium carbonate, along with copper sulfate. We weigh it. After that, what we do is we swirl it. Nicely twist and swirl it and shake it. What will happen? This copper sulfate which is present in the test tube, this will spill inside the conical flask, and both these solutions will react together. And a new substance will be formed, like copper sulfate, which is CuSO4, right? It will react with sodium carbonate, Na2CO3, and a new substance will be formed, that is CuCO3 plus Na2SO4. A total new set of substances formed. Whatever was present here, these have reacted together. Now how this reaction takes place, actually you will learn afterwards in class 10. So copper sulfate and sodium carbonate react together to give copper carbonate and sodium sulfate. But suppose the mass here of copper sulfate we have taken, suppose 2 gram, and of sodium carbonate, suppose we have taken 3 gram. So total mass here is, that is 5 gram. And when we will weigh here, this will, now this 5 gram along with this conical flask and everything, suppose it weighed say 7 grams. And when we will weigh this will also weigh 7 gram. Or whatever, suppose here it was 2 gram plus 3 gram, this will also remain as 5 gram only here plus 2 gram, whatever is the weight of the conical flask and the test tube, right? That mass will not change. And why do we put this cork over here? Why it is important to put a cork? So that when the reaction takes place, if any gas is formed or any vaporization takes place, that do not go out, right? That remains inside only, that then only the weight will be the same. So we through this reaction, through this experiment, we can prove that mass can neither be created nor be destroyed in a chemical reaction. That always remains the same. Then another law was given, that was law of constant proportion. This law was given by Proust, J.L. Proust, right? Now what he said in a chemical substance, the elements are always present in definite proportion by mass. So whenever any chemical substance we take, let me rub this. Suppose we take the example of water, right? We take the example of water. Water you all know is H2O. So in a chemical substance, the elements are always present in definite proportion. What are the elements present here? H and O. They are always present in definite proportion, that is 2:1 by volume and 1:8 by mass. Now how 1:8 by mass? See, 2:1 by volume, that is always 2 parts of hydrogen will combine with 1 part of oxygen. Now how 1:8 by mass? You all know the atomic mass of hydrogen is 1. So here it is H2, we will multiply it by 2. Oxygen, the atomic mass will be 16, right? So 2 1s are 2, 2 8s are 16. So it is always in the ratio 1:8 by mass, right? So if we take suppose 9 gram of water, it will always be in the ratio of 1:8. That is 1 gram of hydrogen will combine with 8 grams of oxygen. And if by volume we take, it will always be 2 parts of hydrogen and 1 part of oxygen. Now this water, from whatever source we take, it will remain the same. Whether we take tap water, we take rain water, we take river water, sea water, even the water from the ditch. From any source we take water, this cannot be changed. It will always have 2 parts of hydrogen and 1 part of oxygen. Or by mass if we take, it will be 1:8 in ratio. We can take another example also. Carbon dioxide. Now in this, carbon is present in the ratio 1:2 by volume, that is carbon and oxygen. Carbon is 1 part and oxygen is 2 parts always. So by mass it will be in the ratio, see, carbon atomic mass is 12 and oxygen is 16. Now it is 2 parts here, so we multiply it by 2. So this will be 12:32. So 4 3s are 12, 4 8s are 32. It will always be in the ratio 3:8 by mass. This is a fixed ratio. Same way, we can take the example of ammonia. Ammonia, nitrogen 1 part and hydrogen 3 parts by volume, right? So nitrogen atomic mass is 14 and hydrogen is 1, and because it is 3 parts, it will be 1 multiplied by 3, that is 14:3 by mass, right? So this we have learned that this ratio always remains the same. This is according to the law of constant proportion. In a chemical substance, the elements are always present in definite proportion by mass. That will never change. So after this also the scientists worked on this, that how these two laws can be worked out, or how the combination takes place, combination of different elements takes place according to these two laws. So that we'll learn about Dalton's postulates in our next lecture now, in the next video. So till then, keep studying and stay healthy. Thank you.